Hello, everybody. It's Paul Spiciali. I'm the CMO at Scality, and this is the Scality podcast. As usual, I'm joined by my colleague, Giorgio Regni, who's the CTO and founder of Scality. Hi, Giorgio.
Hey, hi, Paul. Hi, everybody.
Hello. It's great to talk to you again, as usual. And as we always do, we're trying to look for some interesting and relevant, timely topics for everybody. Today, we'd like to talk a little bit about AI. It's very hard to ignore these days, obviously. Specifically, our topic is to look at what NVIDIA calls their AI data platform. And in order to do that, we thought it would be nice to maybe just start at the very top with the AI data pipeline. So can you give us just a general introduction to that?
Yeah, let me try to give an overview. So the way that our customer use AI, we see two main stages. The stage where you prepare the data. So the data could be videos, could be photo, could be text, but it's not consumable by any of the AI tools. It
Mhm.
needs to be filtered, it needs to be cleaned, removing duplicates, removing low quality data, and then it has to be encoded, which people call the vectorization,
Mhm.
because only the vectors, which is basically transforming your data into something a model can understand. And before you do that, your data is useless, right?
Right.
And the model actually never looks at the data, only looks at the vector encoded version of that data.
Yeah.
So that stage, we call it the data preparation stage, and that's the highest capacity. That's
Mhm.
petabytes to exabyte of storage, and it's really high throughput oriented. A lot of data you have to move through. Then you have the other stage, which you're going to iterate a lot of time. That's the model stage where you actually either training a model, using a model, or fine-tuning a model. In that case, it's all about low latency, extreme low latency, extreme high performance, just because you want to make sure the GPU is not waiting
Yeah. Yeah.
for you to do things.
Yeah, it makes a lot of sense. And like you said, each of these general stages, the data prep and the model, have sub-stages. And then
Yeah.
obviously there's going to be different data set sizes and performance requirements, right?
So if you
So,
want to put some numbers around the
yeah.
different stages, the prep is going to be the biggest one, 100 of
Mhm.
terabytes to petabyte to exabyte. Then you have a lot of accessory storage like logging, security, compliance, dumping states of
Yep.
your model. We call that snapshots.
F20, right?
And that's going to be less capacity. It still can be a lot. Now you're looking at multiple hundreds of terabytes, but it's not going to be exabytes
Mhm.
at that level. And that's interesting because when you look at the acceleration of compute, it's always been done at the later stage, in the training, in the inference, where you want to use GPU and do accelerated computing. With the NVIDIA data platform, you're actually accelerating the left-hand side
Mm.
because now
Mhm.
you want to accelerate the vectorization, the cleaning, and the processing of your data.
Yeah, makes a lot of sense. So I think that's a perfect setup to the introduction of the NVIDIA data platform. Maybe you can give us a general sense of what it consists of.
Yeah, so it's a reference, it's a reference architecture that
Mhm.
vendors can publish with NVIDIA, where the is going to combine GPUs, DPUs, or the networking that NVIDIA provides into an architecture that's going to use NVIDIA software, namely NIM or NIMO, all that stack of microservices,
Right.
to give you an open design, that
Mhm.
you could do with vendor A one day, with vendor B another day as a customer. And
Mhm.
as long as you copy the design, you get the same features in the end.
Yeah, this is certainly a lot of alphabet soup, right? A lot of acronyms, and
Mhm.
maybe we have to explain a little bit about what NIM is. So this is NeMo Inferencing Microservices, right? And what it is really microservices that are optimized, including they have NVIDIA provides curated models, but it includes things like for vectorization and embeddings and retrieval for Gen AI and RAG. But there's a confusion, right? Some people think, well, it's actually the database or the storage system, or it might replace what you have if you have an object store, but that isn't what it is, right? This is really a platform and a set of microservices that needs to be paired with a scalable storage system. And we think obviously object storage is ideal. So something like AI data platform and the Scality ring would be a really, really optimal
Yeah.
combination.
So yeah, to give an example, that's perfect. So the way that the data will be ingested into the object store, as usual, as a big
Hmm.
data lake. Then when it comes time to process that data, it has to be encoded, made into vectors. All the embeddings have to be made, and
Yeah.
that's when the AI data platform from NVIDIA will use the S3 protocol to
Hmm.
get the data from the object store, the actual data, do all the processing that has to be done to it, and store the embeddings back into the object store.
Got it.
Yeah.
Got it.
So the state stays in the object storage system, and the data goes back and forth as needed. And when the data is processed, it becomes vectorized, it's embeddings, and so now it's ready to be used by the model.
Yeah, yeah, it makes sense. The term we didn't throw out yet was data lake, and I think a lot of people know that term, but this is really cool, right? Because it means you can have one object store that is your data lake that you manage simply as one instance. You don't have all these other silos, and you don't have to copy data and have multiple copies to manage, right? So it kind of simplifies the data management.
And so one of the key here is the object store is your main repository for your AI data. You don't have to copy it. Now it stays in place. I think
Yeah,
that's key.
yeah.
And if you have other storage in the company, you could also access them directly via the data platform. And so you're minimizing data movement.
Yeah. Yeah, this has really been a headache for people over 20 years, right? To think about before AI, that you had multiple storage silos and copying data and multiple instances. We're trying to avoid that here, right? So what you described would be really a much, much simpler solution. The other thing I think we wanted to point out is that there are alternative ways of doing this in the industry. Just a quick comparison. If you think about having kind of an open choice, you might want to think about NVIDIA's AI data platform on a software-defined storage system. That's what we advocate, software-defined, hardware agnostic, something that can scale, as you said, Giorgio, so it's a single pool of data without all these different silos to manage. We think there's an advantage in that approach, right? It gives people freedom. They can choose the platform today, the more optimal platform in the future. They're decoupled from the AI data platform, NVIDIA, so NVIDIA can advance that. And it kind of contrasts with what we're seeing in the industry from vendors like Vast, right, who are doing this in kind of a more proprietary way. So they obviously have their own storage array. They embed these microservices. So you end up again with kind of this siloed vendor lock-in approach, right? So would you agree with that?
Yes, I do. And this is about having open reference design. So I
Mm-hmm.
think being all software based goes in the right direction.
Yeah, yeah. And I think that's kind of the simplified way of saying it is pure software on one and software and some proprietary hardware on the other, which does create some lock-in. All right, well, thanks for the conversation. And as usual, we wanted to leave our viewers with a couple of references. There's a lot of information, a lot of videos out there about the NVIDIA data platform. Their website's actually very informative. So I provided a pointer to that here. And obviously, as a vendor of object stores that we think are totally ideal for this problem space, I provided a pointer here to our own page on extreme performance for AI. So with that, I want to thank you, and we'll see you all on the next time.
Thanks,
See you later,
everybody.
Giorgio.